Hey friends, now we will see that descriptive statistics. So today we will discuss on data that is on cardio fitness case study. So let's start here. We will see all the terms related to statistics, and this is the problem statement that the market research team at White is assigned the task to identify the profile of the typical customer for each treadmill product offered by cardio good, right? And this is nothing but a fitness. All right, so the market research team decides to investigate whether there are differences across the product lines with respect to customer characteristics, right? So the team decides to collect that data on individual who purchase a treadmill at a cardio good fitness. Okay, so there also the time is provided, that is per 3 months, right? So the data are stored in the this CSV file that I'll provide the link in the description. Now the team identify the following customer variable to study. Okay, these are product purchase and these are some values, right? There would be some gender, age, and sort of no number of columns and their values. So what it is asking is perform descriptive analysis to create a customer profile for each cardio good fitness treadmill product lines. Okay, so we just need to do a sort of descriptive analysis here. So for that we need some necessary library, that is NumPy and Panda. We imported them, and this is the data set that we are loading, and this is the top 5 rows in a data set. These are product, age, gender, education, marital status, usage, fitness, income, and miles. Okay, now if we try to get the descriptive analysis, or we can say the description of our data, where it is, if we get the description of our data, or we can say if we want to describe it, where we include all the parameter that we want. Okay, so here you can see that we got the count for each column, then unique, top, frequency, and so on so forth, like the interquartile range and all. Okay, if we get the info that how much columns are there and what is their data type and how much then values are there. Okay, and now what we are going is we are trying to plot the data in a histogram. Okay, so we are importing matplotlib, right? And we are providing the fixed size of 2030. So here you can see that this is the data inside that data set, which is in my data. All right, so you can see that these are the plots. So this is first one is respective to age. Okay, so you can see the age graph here, the education, the fitness here, the income, miles, usage, and all. Okay, now if we plot the box plot, so for that again we import the seaborn. Okay, and we want to plot the box plot based on the gender and age. So gender is nothing but our x-axis and age is our y-axis, and on which we want to perform the operation, that is on my data. Okay, so here you can see that we got the box plot here. This is nicely plotted in the interquartile range format. Okay, if we get the cross tab, okay, as I discussed that what cross tab is, basically imputes two or more tables no imputation, right? So here you can see that we got for the product and gender. Okay, so gender we have is male and female, and this is the product. So on the basis of product we got these values, right? Now if we perform the cross tab for product and marital status, here you can see that this is a product. Okay, and for marital status, whether it is partnered or it is single. Okay, so these are the value that we got. Now we here plotting the count plot. Okay, so the count plot is based on the product that we have and the gender, right? So this is the gender, you can see that, and count is up to around it is 39, we can say. Okay, 38 to 39. So here you can see that the product and the gender respectively. Now if we do a pivot, all right, so what it will give us, we are doing pivot table on the my data, and where the index would be our product and gender, right? So there will be product, and here it will return the gender. Okay, and the column are marital status, and augmented function is based on the length, right? So here you can see that for each product, right, we have values for male female, then we have partnered or single for male female respectively, then we have education, right, for male female both, then fitness, income, miles and uses. So here you can see that we are getting there for marital status. Here for each column we are getting partnered and single, again for education partnered and single, fitness partnered and single. All right, so this is what the we got basis of this pivot table. Okay, now what we are doing is we are telling that okay, just perform another pivot table on my data based on income. The index should be on product and gender, right, and the column is marital status. Okay, so here you can see that based on the product and the gender, right, and the marital status should be whether it is partnered or single. So here we got the pivot for that. Now in we are aggregating and summarizing the data using this pivot table. So here now we are doing on miles, okay, and the index are our product and gender, right. So here you can see that again product and gender. Now the value are of miles basis on the marital status. So if we get the pair plot for my data, here you can see that this is for age, how the age behaves here. Okay, this is for education and this is for usage. Here you can see that diagonal we got the bar graph, right. So yeah, next if we want to get the standard deviation, we just use the std function, but remember that it will apply on the column that has this integer value or float value, right, and this is how we got the standard deviation. Then if we want to get the mean of any particular column, so we call the mean function. Okay, here we are plotting dist plot, right. So by using sns.distplot we are performing that on A. So here you can see that it is a bit symmetrical, right. So this is how the dist plot look like. Now we are telling that okay, on my data plot histogram based on gender and column should be our age. So based on gender, whether it is female or male, okay, and the column will be our age, so it has written the value. Now based on gender and column would be our income. So if income is 40,000 for female, so it is coming on the this position. All right, and for male as well, if we check the 40,000, it is a bit similar. Okay, while if we check for the 60,000, right, so it is a bit high for female and low for male. Now if we are checking hist plot for gender, okay, so for female and male, and this is for miles. So if it is 100 miles, so what is the value from female and male? If it is 200, what is the value, so on and so forth. Now we are plotting hist plot for product, right. Basically now we are plotting the hist plot. Here you can see that we are passing by, so by the product, and the column is miles and fixed size is that. So this is our fixed size, and here you can see that this is our product. So first product, second product, by using this by argument, it will perform for all. Okay, here for product it has given me this. If we check the correlation, so again we simply have a function that is core, which will return all the correlation value for each column that we have. So for age you can see that age it will look like this. For education age, the correlation is this much. For education and education, the correlation is 1. So here you can see that diagonal it will be always 1, just because for age there will be nothing, right. So if we compare it with other, so then only it will return the correlation. If we map that correlation using heat map, so it is how it will look like. So again diagonal, you can see that it is always 1, right, and for non-diagonal value it will return the correlation. All right, thank you.